Hello and welcome to the Best Practices Summit. Pollinator Friendly Alliance is a grassroots 501c3 nonprofit that protects the natural world through the conservation of pollinators. Our co-host is the Xerces Society, a science-based nonprofit.
Okay. So I am John Lundgren. I'm director of Ecdysis Foundation. I worked for USDA ARS for a number of years, and about 6 years ago, I quit, and we started something totally different. We're trying to use science and become the scientific infrastructure behind this movement of regenerative agriculture. We'll talk a little bit more about what that is, but it is likely the solution to the bee problem. Okay. The bees are dying, right? I ask people, beekeepers, when I give talks for bee clubs, when did the bees start dying? Oh, 2008, something like that, 2006. And then I ask, how much have we spent on trying to solve this problem? And the answer is millions of dollars, hundreds of millions of dollars over the last 14 years. And then I ask how the bees do this year. And the room usually gets pretty quiet because we've lost just as many bees as we did 14 years ago. How's the expenditures working? Is the question that I think we all need to ask ourselves. The problem is that this was never a bee problem, but we treated it as though it was. And until we realize that, your bees are going to continue to die, okay? And much more than your bees are going to continue to die. What is the problem? If this is not a bee problem, what is the problem? Well, we're not just losing bees, right? I'll get to the problem here in a second. But first, we have to realize that we're losing many more things than bees. We are currently experiencing on planet Earth the worst mass extinction event that has ever plagued our planet. Okay, we're not just losing bees. We're losing entire habitats. We're draining wetlands at a rapid clip in the US and beyond. Grasslands, where'd the prairie go, right? Entire insect communities were down to 60% of the biomass that was present in terms of insects. We call it the windshield test. This is the insect apocalypse, but it's much more than that. We're losing, yes, bees and butterflies, but we're also losing birds. We're losing bats. We're losing mammals, and at a rate that this planet's never seen before. Okay. What's driving this? Well, it's right there on your slide, right there on your computer. It isn't soybeans. It's how we produce our soybeans. Agriculture is currently the dominant biome on planet Earth, terrestrial biome on planet Earth. And it has become far too simplified. And that simplification process has led to dependencies, okay? And until we fix this, your bees are going to continue to have problems. What am I talking about? What does this mean? Oh, simplified. What does that mean? Well, here's some data that might help illustrate that. Corn in the United States, this is the continental 48 states. It currently occupies 5% of the terrestrial land surface of our country. Soybeans represents about 4.5%, wheat about 2.5%, alfalfa is 3% on 15% of the terrestrial land surface of our country is 4 plant species, where once there was hundreds, now there are 4. We often read on the side of a jug, warn your beekeeper before you spray this. This is where I live, right here in eastern South Dakota. When a beekeeper sees this or hears this, and is living in this yellow as corn, green as soybeans. When they're living in this matrix, they ask, where the hell am I supposed to move them to? Right? Because everybody in the county sprays at the same time. Usually the same poop gives the same advice to everyone at the same time. That's how they make their money. The problem is that the land has become far too simplified. There are outcomes of this, because when you eliminate diversity, when you eliminate life from an agroecosystem, you eliminate everything that that life used to do. All right. Biology, biodiversity is wonderful, not just because we love species, but because these species do things. They are the way that we maintain the productivity of our system. And when you eliminate that life, you have to maintain the productivity using other means. And we replace what life used to do with a jug. And no matter what it says on the side of the jug, whatever it says it's supposed to do, it all kills bees. Herbicides, fungicides, insecticides, fertilizers are all having non-target, unpredicted, unexpected consequences on the natural world. A few years ago, a friend of mine reached out from Montana. She said that in her county in Montana, they were actually experiencing weird things with the white-tailed deer population. 70% of these deer had, the males had genital deformities. 70% of them had these weird jaw deformities. And they asked whether or not neonicotinoids might be contributing to this. Neonicotinoids are insecticidal seed treatments. When you see a landscape like this, you see almost 99% of that ground is treated with neonicotinoids. On one corn seed, there is enough insecticide to kill 164,000 bees. Okay. So she asked whether neonicotinoids were working against the white-tailed deer. They might be having this unintended consequence against white-tailed deer. And we got a master's student. Her name was Elise Hughes Berheim. She's a wonderful lady who did an incredible study that will never be replicated again. We, together with a colleague at South Dakota State, John Jenks, we conducted a toxicity assay of imidacloprid, one of these neonicotinoids, against captive white-tailed deer populations. So it's a 2-year study. We looked at the female performance as well as her offspring's performance. And we administered this toxin to them in their water at field relevant rates. The dead fawns ended up having more imidacloprid in their spleens. The spleen was the magic organ. We found that the spleen contents ended up being correlated, strongly correlated with many of the different fitness metrics that we were trying to look for. So you'll hear a lot of spleen contents in the next few slides. More imidacloprid in the spleens of these deers was associated with reduced fawn body weight. They were smaller. That means their organs were smaller. Their hormones were disrupted. That's important. The bees' hormones are being disrupted. Fawn jawbone lengths were disrupted. They were significantly shorter. They had an overbite. Sounds familiar, right? And the activity levels in the adult deer, the more imidacloprid that they had in their spleens, the slower they were. What's a slow deer in the wild? It's a dead deer. We were criticized. The people started to come. They said, wait a minute, that's what you're able to force feed into these animals under captive conditions. That's not realistic, right? This was the quantity that we were able to generate in our deer. North Dakota decided to send us a whole pile of deer spleens as a result of this from hunter-killed deer. Minnesota sent us another 800 recently. That study hasn't been published yet, but it's coming out soon. This is what we found under natural conditions. 3 times what we were able to generate that saw these fitness impacts. under captive conditions. What are we doing? What are we doing to our bees, to ourselves, to our kids? Wake up. It is time to wake up. We don't have time for this anymore, folks. I started to meet farmers all over the world, in fact, and they started coming to me and they said, wait a minute, John, we don't have pest problems. We're not concerned about neonicotinoids because we don't use them. We don't need these things. And I said, wait a minute, that's not supposed to happen, right? Pests are inevitable. As entomologists, we're trained that pests are just a sure thing. You have to count them. And then when they reach a certain threshold, then you buy a jug or you react to that pest. What these farmers said is, no, we're growing normal crops. We're doing it differently, and we don't have pest problems anymore. They didn't know it at the time, but these farmers were the precursors of what is now being called regenerative agriculture. They started with things like no-till and started cover cropping. And as they started to diversify their farm, they found the pests weren't an issue anymore, and they didn't need pesticides. This prompted us to run a study, a real eye-opening study for us, because it changed the way that we do our science. This was back when I was at USDA and almost was the precursor to us starting Ecdysis Foundation. I got a grant. That's what scientists do, right? We have a great idea and we sit down and we write it up and we get money to study it. And this grant was intended to study the effects of cover crops on pest management in corn. And so we got this money, and then I reached out to some of the top cover crop producing farmers in our region. And I said, I got this money. Do you want to participate in this study? And they said, yeah, we'd love to get some science on this. I said, great. As a scientist, I'm the expert. You're supposed to replicate this study on your farms. We want 4 pairs of untreated versus cover crops, okay? And they've got to be this dimension. You've got to plant this thing, and you've got to have these covers, and you have to manage them in this way. And the farmers started to say, wait a minute, John, that's not how we roll, right? We don't plant that variety of corn, or we don't plant those cover crops, don't work, or we don't use glyphosate on our farm. And the study crashed and burned. The next year, I took a different approach, a humbler approach to science. And I said, you know what? I am not the expert. Last year, by me imposing my knowledge upon you, I lost what was special about your farms. You guys are the experts. Please point me in the direction of your cornfield. I would like to observe. And then they did that, and they pointed, then I said, point me in the direction of one of your neighbors who's a conventional farmer who's very successful. And they did that. And that became the precursor to the first study that was ever empirically conducted in the primary scientific literature. This was Claire Lacan's work for her master's degree. In one day, this study reached the 99th percentile, the top 1% of all science ever written in terms of social media impact. Not bad for a master's product. She went out. What was so special about this research is that she went out, and instead of predefining best management practices, she went to the experts and said, you know what, you have successful systems. And so it was farmer defined best management practices. It was a regional focus. It was in North Dakota, South Dakota, Minnesota, Nebraska, pretty important honey producing states. And it was systems focused. It wasn't just a component. It was the whole system that we were starting to examine. There were differences in many of the practices that were implemented, but in regenerative, no insecticides were used, and in conventional, all of the fields were treated with neonicotinoid seed treatments, and they were treated with BT corn. They planted a genetically modified hybrid corn. And then we collected entire insect communities, and we looked at the yields, and we looked at the profits. This is what we found in this study. The insecticide-treated cornfields had 10 times more pests than their regenerative neighbors, the ones who never used any insecticides. That wasn't supposed to happen. What they did that was so special is that they replaced pesticide use with good management. And when they did that, they found they didn't need pesticides anymore. They didn't have to spend the money. Profits were twice as high. Yields were about the same, even a little bit lower in the regenerative farms. They were learning as we were going. Those yields are now equivalent. Why were they so much more profitable? They didn't have to spend the money on all the inputs. The fertilizer costs were substantially lower. The seed costs were substantially lower, and they marketed their product. Some of them just sold it to the coop, but some of them kept it within their community. It was a good business decision, wasn't it? We asked these farmers, where we looked at these farmers, and we found that yields actually were not correlated with profit because they were spending so much money in order to generate the yields. The profit of these systems was correlated not to yields, but to how much soil organic matter they were generating on their farms. We need to be giving prizes not to the top yielding corn farmers in a state or a county. We need to be giving awards to the top producers of soil organic matter, who's restoring their soil the fastest. What is this thing, this regenerative agriculture? Well, normally farms focus on profits and nutrient-dense food, okay, or yields. In Regen Ag, they've turned their focus onto soil health and biodiversity, life on their farms. And when they do that, they find that they're more profitable and they're producing more nutritious food as a result. And so those are the outcomes of a regenerative system. The key outcomes of a regenerative system are increasing soil health, life on the farm, while growing nutritious food profitably. And there's many trickle-down effects. Soil carbon sequestration rates go up. Water, you end up seeing these dynamics with the water in the soil that can reverse desertification. Farm resilience is improved. Premiums, profits are achieved and attained with these regenerative systems. How do they do it? Number one, to save the bees, you have to heal the soil. There's no other way of doing it. The solution to the bee die-offs and the biodiversity loss will not be attained unless we heal the soil. Start that by stopping tillage. That is the worst thing you can do to your garden or farm. It removes life from your farm. And it stops the productivity of that soil. That then you are necessitated to replace that productivity with jugs. Never leave bare soil. Where does the energy come from that drives the productivity of a habitat? It doesn't come in a jug, it comes from the sun. And the only way you catch the energy from the sun is with plants. So some plant diversity is better than none, and more plant diversity is better than less. And one of the really important ways that we need to maintain those plant communities and increase the resilience of a farm is by incorporating livestock back in. Livestock comes in many forms: sheep, poultry, cattle, bees. And then finally, a fifth principle that unifies all of these operations is whether or not you are able to eliminate or drastically reduce your agrochemical inputs. I'm a beekeeper, I'm a farmer myself. The honey is one of our main outputs from Blue Dasher Farm, which is our operating regenerative farm that Ecdysis currently resides. I followed the bees out to almonds, and I realized that most of the nation's bees head out here, and anything that we're doing to try to save bees in the upper Midwest are completely negated when we move out to almonds. So I decided and met Tommy Fenster, who became a master's student. He's not a candidate anymore. He's actually a doctoral student now, studying vineyards. We asked, I mean, we tried to get people interested in this topic. And the industry responded with soil health won't work here. And so we decided we had to find some regenerative almond producers, and they were diamonds in the rough. They were not apparent, but we found them. Tommy found them. And we did a fence line comparison similar to the way that Claire did. This is not Photoshop. This is two of our experimental blocks, actually, two operating farms. Regen on the left, conventional on the right. You can see the different practices that are used to generate those two systems. What did we find? These regenerative orchards sequestered about 30% greater carbon rates. Soil health, this Haney soil health test. Didn't think you'd be seeing a lot of soil health at a beekeeper meeting, did you? But that is really important. And if you take nothing else away from this, this is it, okay? Soil health significantly improved. Water. This slide alone will change the almond industry. This slide alone is changing the almond industry. We just got back. It's starting to change. The avalanche is starting to fall. Regenerative, when you're farming in a desert, it doesn't matter how much water you get, it's how much you hold on to. And regenerative orchards had a 6-fold higher infiltration rate of water. They sucked it in, whereas in conventional, it hit the ground and ran off. Life on these farms was substantially greater. Pests were very low in both treatments and were statistically identical. And when we showed our producers this slide, one of our conventional producers was sitting at the table with us and he said, I don't believe it. I can't believe it. I did everything I was supposed to do. I followed the best management practices of the almond industry and the universities, and I sprayed insecticides 5 times last year. And what you're telling me is that the guys right across the road that didn't spray at all had the same number of pests as I did. And I can't believe that. But it wasn't just him. And that's the power of science and the power of how we're conducting science. It wasn't just the neighbors. It was all of the regenerative farms. Replicated, statistically robust. And based on that data, that almond producer changed 160 acres last year, and now he's converting his entire 1,000-acre orchard to regenerative. That is the power of science. Really important right now. Yields were statistically no difference. You can feed the world using regenerative, and profits, again, twice as high. Okay, it's a good business decision to go this route. There's much hand waving going on right now regarding regenerative. What is this thing? There's a lot of labeling schemes and verification scores, and nobody's got any data to support these things, whether it's actually producing the things that it's supposed to. And so we developed a scoring system for both croplands as well as rangelands. 2 different systems, in fact, that are pretty similar. And then we spent $1 million to test these systems over many years of research. A lot of work went into this. It's published down here. It's open access. Anybody can have it. It's free. In 2 minutes, with 10 yes or no questions, we can rank a farm, a crop farm, based on its how many regenerative practices that it's employing, and start to make some predictions in terms of outcomes, in terms of economics, soil carbon, water, life, all of these things. It's a very simple system that works. In rangelands, it gets even easier because there's only 4 questions. Do you use agrochemicals? Do you keep a lot of animals on your ground? keep them tight, move them frequently, and allow that pasture to rest. If you do, you end up seeing a lot of positive outcomes. So this system that we developed has to be simple, transparent. It's got to transfer among different systems. It always has to work no matter how small or large you are. It can't be corruptible. Look at what happened to organic. And it's got to be replicable. It's got to work. So I think that this system is a good starting spot. We're hoping that, and more people are starting to pay attention to it. And so we're hoping that this can be a useful tool. This is Dr. Ryan Schmid and Tia Buzenitz. These are two of the wonderful people that I get to study with. And they decided that they wanted to see whether or not honeybees benefited from rangelands that had higher scores on our regenerative matrix. And so we ran a pilot study. We couldn't get money for this, don't be crazy. So we ran a pilot study last year to show this works in South Dakota. And so they put hives out on these two systems. These are the regenerative rangelands. They're on the right, and there's your conventional rangelands. They're on the left. And we put, I think it was like 16 hives on each of these different systems. And we monitored those hives monthly over the season. The hives grew faster on the regenerative rangelands based on hive weight, pounded on honey at a greater clip. And this was consistent throughout the season. Okay. Brood counts, they were did not differ significantly, except on a few dates later in the season. You ended up seeing greater brood production later in the season on these regenerative rangelands. Varroa was kept below economic thresholds throughout the entire season on the regenerative. You do not have to use acaricides if you're putting your hives associated with regenerative rangeland systems. That could change the industry, huh? How about it? We can make agriculture conducive to life again. Honestly, we don't have a choice in the matter, okay? Time's a ticking. And so that prompts us into creating Ecdysis Foundation, the largest agricultural experiment ever attempted, okay? We have a ragtag team here of Mavericks here in Eastern South Dakota. And from this headquarters, we are changing the world. It's been so exciting to watch. Very simple outcomes or goals of this, right? Simple in presentation, very, very, very challenging in terms of implementation. We are trying to change 3.5% of all farms in the US to regenerative within the next 5 to 10 years. Why 3.5%? Because nonviolent revolutions, that is kind of this tipping point. You don't get there. A revolution does not self-perpetuate below that level, by the sounds of it. Somebody at Harvard has done the work on that. So we've made that our target, just 3.5. That's only 75,000 farms. So I think we can actually do that. Number one, we are validating, we're testing the hypothesis that regenerative works no matter what you grow or where you grow it. Number two, we are creating roadmaps. The farmers are creating roadmaps to successful transition, and we can empirically evaluate these things to develop a clear path forward for folks. Number three, we are communicating these findings as widely as we possibly can. And number four, we are monitoring these things such that we are asking the question, does regenerative actually produce on the promises that it makes? On each of these 1,000 farms, we are conducting full systems assessments, soil, deep carbon, micronutrient status, physical properties of the soil, water, holding capacity, infiltration rates, microbial communities, invertebrate communities, plants, birds, mammals, nutrition of the crops and forage, and then the economics or profitability of each of these 1,000 farms per year annually. These are some of the key systems, but we're also allowing farmers to help us to guide what systems we are evaluating. And so these are some of the dominant ones in each of the ecoregions that we've kind of partitioned across the continental US. And so we're also, we just started recruiting for this. We already have more than 700 farms have registered their farms to be studied for this. It's been about a month. So we're not going to struggle to find field sites. Let's put it that way. For this work, I mean, nobody's attempted something like this. We've standardized methods, we've automated things. We're actually sending field teams to each of these farms. And the result is that we need to develop entire new technologies in order to try to automate this and make this a reality at a rapid clip. So we're developing entirely new ways of characterizing microbial communities in the soil. We're developing image recognition software that should be able to identify invertebrate communities with minimal efforts. Machine learning has tremendous potential, and we're currently training that system right now. Have a lot of hope for that. There's also unprecedented opportunities for collaboration, especially with things like beekeepers. We need to have hives out on these 1,000 farms if we're going to be able to show this is the answer to the bee problem. We need empirical data and performance on each of these hives. But we're also collaborating with people that are developing entirely new tech. They need an experimental scaffolding in order to calibrate some of these new ideas. And then we're also ground truthing some forecasting efforts. So when we say that agriculture can, reverse climate change, you know what? You actually need data on the ground data, and we're generating that. So ways to contribute. We need farmers. Beekeepers are the best connected people within their agricultural communities that I've ever met. That is one thing that I have learned at a very rapid pace. Please, if you know of people that are doing the right thing on their farms, have them register their farms or reach out to us, because we need to be looking at these best management practices that the farmers are generating. We need support. If you know of other things that are going on that we can dovetail this initiative into, we need those contacts now, not later. And then also, it costs us $7,500 for each of these fields in order to run it. That's not us making a bunch of money. That means that's the labor and processing costs that are associated with each of these things. Consider sponsoring farms. We need your help in order to get this done. We want to keep it free for farmers as much as we can. In this life, these problems that we are facing, the bee die-off, climate's shifting, new diseases that are hitting the human race, all of these things seem like absolute monoliths, right? It can be so daunting. In our lives, each of us is required at some point to be more than what we are. And that time is right now. Change your life. Be the pebble that starts that avalanche. Because on this call right now watching, I see the numbers. There's almost 300 people that are little pebbles that each can start an avalanche in your own communities and lives. Please be that. Many thanks to many people without whom we would not be here, especially the staff that you see, plus there's so many more that should be on this slide. And I apologize for that. But if you would like to learn more, if you would like to register your farms or reach out, please take a look at our website. Ecdysis means shedding the old skin. Metamorphosis seems pretty appropriate. That's our 501c3 nonprofit for research and education. And Blue Dasher Farm is there. That is our regenerative operating farm. Stop by if you want to see something that you've never seen before. Follow us on Facebook and Twitter. And I think I have a little bit of time that I could field some questions or thoughts.
Oh, great. Yeah, John, your talk is necessary, important information, and there's quite a few change makers that thankfully are on the summit with us. So are wondering, where can we send them to find some of the results from your research and your work?
Follow us on Facebook. That is the quickest way for you to see the publications when they're hitting. And then we all upload all of our open access research is available on our ecdysis.bio website.
And again, everybody, we have a summit page, which is pollinatorfriendly.org/summit. I will connect with John after his talk today, and we'll get some links and put them up there for you to find more information as well. So John, can you talk a little bit about GMO seeds in particular? I'm not sure people realize how destructive they are in terms of not just the covering when they're planted, but also the combination of pesticides that they're companion to.
Sure. So, I worked on this very topic for many years. I helped advise the EPA and some of their risk assessment formulae, especially, and then also the European Food Safety Authority. Genetically modified crops, I think, in terms of toxicity, direct toxicity, they typically aren't particularly toxic directly that we can measure in ways that we can measure. How they're adversely affecting the environment is the way that they're reshaping agriculture. And we would not have a simplified agricultural system if it weren't for genetically modified crops. They are a necessary tool for us to move forward with this monoculture-based agriculture. So, and you're right, they're associated with things like glyphosate, which has known it's known to through the published literature that this produces learning disabilities in our bees, as well as disrupting the microbial communities of their guts. And so, yeah, and there's knock-on effects that these things end up having.
How many GMO crops do you think are actually paired with a pesticide? So if you plant a GMO soy crop, then you're going to also be using an insecticide with that as part of their.
Yeah, all of them, right?
Yeah.
Almost all of them.
Right.
Yeah.
So what about turf, Jonathan, compared to pesticide threats and from industrial agriculture, where do you think turf as, say, I've heard the statistic turf is the second biggest crop in the US. What do you think about that?
Oh, that's interesting. In terms of acreage, no way. In terms of input costs, probably you might be getting there. We put a lot of stuff on our turf. One of the things that, you may end up getting your eyebrows raised within your neighborhoods, but if you're serious about the bees, replacing your lawns with pollinator gardens and native habitat would go a long way to raising not only awareness, but also having an impact on local pollinator communities.
Right. So speaking of scale, what about the farms that you're choosing to work with in the 1,000 Farm Initiative? Are you trying to have large, small, medium, or do you need to sort of stick with the smaller?
No, this is totally scalable, right? We find that regenerative works no matter what farm scale you're looking at. For our experimental design, we're kind of targeting farms that represent the mean farm size for that particular food system. So, so that's been our strategy, but we're depending on the system that we're studying, we accept minimal sizes and up to whatever people can farm. So,
have you gotten the response from farmers often that I don't want to say excuse, but there is no market for alternative grains. The industrial farmers that are growing corn and soy and wheat. What's the answer to that?
So sounds like a business opportunity to me. So let's think outside the box a little bit. There's no shortage of excuses that people can use for avoiding changing. And the question that I end up asking farmers that say, regen sounds good, but what's it going to cost me to change is, that's the wrong question. What's it going to cost you not to change? It's going to cost you your farm. It's going to cost you your grandkids. For beekeepers, it's going to cost you your business. So it's time for all of us to start really starting to hunker down and think about what that cost of change is, or rather what the cost of not changing is, because the status quo ain't getting us where we're supposed to be, is it?
Right. So you're in a unique position, John. You're a experienced beekeeper, a researcher, and now you're also a farmer. So we have a couple of beekeeping questions relating to migratory beekeeping and placing hives on commercial crops. Can you speak to the health of that for bees for a minute?
So we were moving bees for a long time before colony collapse hit. But there has been a simplification of the bee industry as well, where very few sources of queens are basically repopulating America's bee industry every year. That's problematic. And that's probably a symptom of this greater simplification of bees within the US. Finding homes for bees and starting to select for genetic strains that can overwinter within this matrix of agriculture is going to be a paramount of importance. We don't move our bees. We leave them here. We also don't treat our bees. We've had a lot of dead bees, but we're starting to get genetic strains that can last. And so.
That's great. Can you talk a little bit about the difference, if there is one, between organic and regenerative farming? Seems to be a little confusion.
Yeah, there's regenerative is usually organic, but not all organic is regenerative. So you can think of it that way. Organic, the certification for organics tends to be practice-based and what you can't use. It's an exclusionary kind of a thing, whereas regenerative is more principle-based and kind of driven by which practices end up attaining those principles. If we look back throughout history, the ideas and the tenets that organic started with was very similar, if not identical, to regenerative. But somewhere along the way, they became replaced by things. And I think that the labeling scheme probably contributed to that. One tool that is allowed within organic that is not allowed in regenerative is tillage. And that's a really important distinction, I think.
Okay, so here's one more question about industrial ag, and this is relating to the really large corporations. How is that impacting regenerative ag efforts?
So corporations are actually getting behind this. We're hoping it's not just all greenwashing. There are some corporations that believe in this as a solution to many things, and they want their supply chain to reflect regenerative. And so this could be a really useful tool. It is the future of food production. And so as companies, if they don't find that are highly successful within an industrialized simplified food system, if they don't adapt, they're going to go out of business. And so, are they impeding it at this point? We're real concerned about that. We have to be very careful. One of my friends reached out and he said, John, we love your scoring matrix for determining whether a farm is regenerative or not. We're trying to change 80 million acres over to regenerative in the US. But the problem is that when we look at your scores, our farms don't score very high. And I say, you know, if you lower the bar low enough, the whole damn country is already regenerative. So it is important for us to have these thresholds and some sort of quality control. But that isn't my job. That's the job of people that are far smarter than I am. So we'll provide data that hopefully can support that, but that decision-making process, but I'm keeping my hands and nose out of it.
All right, here's one more for you, if you will. It's back to your honeybee talent. Can you comment a little bit about managed honeybees and the interaction and in terms of health between native bees and other pollinators?
Right. So I think we need to I think we need to fix the ship instead of bickering over who gets to stay on the lifeboat. If you were to weigh the cost of honeybees on native pollinator populations versus the impact of large-scale landscape changes associated with agriculture, you would find that if you were to remove the honeybees today, native pollinators would be in the same boat they are right now. So honeybees are not the cause of this. It is our food system. Let's fix that. Fix the ship. Okay.